All right, welcome everybody. Yeah, for those who have never met me, my name is Tony Kai. I'm one of the sales engineers here at Nerdio, and today we're going to talk about how to actually decode in Azure SKU, right? And how to unlock some performance out of your virtual machines, right? So this is particularly useful when you're either using the cost estimator and there's you hit the drop down for the list selection of a VM SKU, or even if you're using the Azure calculator, you click on virtual machine, you hit the drop down. There's almost like a million different combinations of different 2-core 8 gig machines, right? Now there's a reason why there's 40 different options for a 2-core 8 gig machine. Each of them are individually different from each other, and so what a lot of MSPs do is when they need a 2-core 8 gig machine, they just hit the drop down, type in 2-core 8 gigs, and then just pick one by random, right? So if you're doing that, you're kind of doing it wrong because there's a reason why they're all 40 different types of 2-core 8 gig machines, and you need to precisely understand why and be very intentional with the one you pick. So and then we'll talk through, VM is also, virtual machine is what primarily people think and associate with performance of a VM. But a lot of times it's actually not the CPU type or the amount of cores that deliver the performance, right? A lot of times it's actually storage. And it's one of those things that people who are comfortable with managing on-prem environments don't really think about, right? So we'll get into those topics today, and then hopefully by the end of 30 minutes, you'll understand how to pick a VM SKU that works and matches with your workloads, and how to match it and pair it with the type of storage that unlocks the best performance out of that VM. So I'll start by kind of setting the stage. Um, to really start understanding why there's so many different SKUs in for a particular 2-core 8 gig RAM machine, you have to understand how Azure or Microsoft designs its data centers, right? So just starting with the data centers and regions. Microsoft has over 65 regions around the world globally. Each one of these regions are multiple data centers that make up a region, right? So all these regions that Microsoft has, they're all connected by physical fiber cables that are private to Microsoft, right? So between North America and Europe, for example, they literally lay like underwater fiber that's specific to Microsoft traffic only to connect these data centers together. Right, so Microsoft has these security professionals that kind of exist in their network fabric that basically monitors for DDoS attacks and everything. But Microsoft has a shared responsibility model where just because you throw VMs up in Azure, you're 100% still responsible for them. And the third thing, just a quick intro to Azure, is that we use Azure every single day, whether we know it or not. Right? I know when you're out there selling to customers, a lot of times customers says, "I want to see my physical server," right? But you kind of have to remind them gently that if you've been using Exchange Online or M365, or their kids play Xbox, or they use Teams, or the new ChatGPT, that they're all already using Microsoft Azure services, right? And a lot of times they've been using it for well over 10 years. So when you go out there and try to sell them a server, and you tell them it's running in Azure, just remind them that their data has always been in Azure, and quite for a long time, most likely. So in Azure region, it consists of multiple what Microsoft calls availability zones. So availability zones are like carved out regions within a region, and inside of them, each availability zone has multiple data centers, and inside of each data center has multiple redundant internet network, and redundancy from a storage standpoint, right? So but I show you this because you need to understand the vastness of a region to understand how you get the best performance out of a particular virtual machine, right? So just to give you an example, this is a region inside of North Europe in Dublin. And you can see it's a newer region. It only went online a couple of years ago, and you can see that there's future campuses or future regions or data centers that are within this region that they plan on making. But if you look at the right side in Dublin 8, 7, and 6, you'll notice little containers, right? These containers are actually Microsoft's latest iteration of what their data center looks like. So when we think of a data center, we think of a colo location where you rent racks out and you kind of fill the racks out with the hardware you purchased, and you get UPS and power and cooling onto that, right? The way Microsoft does it, they're up to generation 6 right now of their data centers. They actually look like containers, right? So Microsoft pre-builds these containers. It's all Microsoft own hardware. So inside this container contains, compute, storage, networking, all packed into one container. It's like a shipping container, and all they do is really stack the machines on top of each other, right? So these containers are petabytes of data inside of them, right? And Microsoft a couple of years ago did some research and realized that, hardware actually performs fine at like 95 degrees temperature. So if you guys are out there wondering why, your client's 8-year-old machine just won't die, it's because the hardware is actually designed to tolerate higher temperatures than you think. So when Microsoft discovered that, they were able to roll out these modules, stack them on top of each other, and not use water or air cooling. They're just using passive air cooling through their containers, right? That's how they kind of cool their data centers and their hardware. But the number one cause for sort of performance issues in Azure has everything to do with IOPS and latency. So in the beginning of the call, I kind of talked about how most people think about the speed and performance of a machine and associate that with CPU. And you're not wrong to associate that with CPU. That's just kind of how most people have treated on-premise. But in Azure, storage actually has a lot more to do with performance than you think, and we'll talk about why. So if you think about a server that you're used to kind of purchasing and racking, I know this is a super micro chassis, but imagine this is a HP DL380 server, right? You have a storage up in the front, you have your RAM on the same motherboard, you have processor on the same motherboard. So when you're reading or writing, whatever workload you throw on it, the application probably performs pretty well, right? It's not something you really think about. And in fact, when you buy a piece of server, you think about how much RAM that customer is going to probably use over 5 years, how much storage they'll use over 5 years, how much CPU is enough cores, to sustain their workloads for over 5 years, right? But you never really think about the IOPS that an application needs. All you really think about from a storage standpoint is when you're purchasing a server, you care about how much hard drive disks it has, right? How much what RAID type you're going to deploy when you set up the server, and what size write back cache better you select when you're ordering the server. So those things matter in an on-premise world, but in Azure, none of that stuff matters because when you rent a disk from Microsoft, you can assume that it's inherently redundant. You don't really care about the RAID type because all that stuff is abstracted from you, and stuff that you never have to think about. But because you don't have to think about the RAID stuff, you have to think about other things that matter a lot more in Azure that didn't matter on premise. So I'll kind of go over what those things are. So this is another example of a region, right? So this is United Arab Emirates, UAE in Dubai, right? This is again one of our newer regions, and inside these different data centers, when you deploy a VM inside of a local area network for a customer in Azure, Microsoft can, in theory, put your VM in one part of the region, right? And then if you spin up, let's say, a QuickBooks server, you're over down here on the left side. That's where your VM could be placed, right? But if you spin up a virtual desktop or another server, Microsoft can decide to put your VM somewhere else, right, far away, in the same region, right, but possibly in a different availability zone or a different part of that region. So because Microsoft's so vast, there's literally millions of miles of fiber connecting these the service fabric together. You can, in theory, put everything in the same local area network, but when you ping two VMs from apart, right? Let's say you had a QuickBooks server and you ping another machine in the same network, you can, in theory, get 3 to 5 milliseconds response rate between the two VMs. Now, for the most part, most people don't have workloads where that sensitivity kind of matters to the performance. But if you have a latency sensitive SQL server, at 3 milliseconds is going to actually make your application perform poorly, right? So just know that when you go and deploy stuff inside of Azure, the way that the software-defined data center works is you don't get to really pick where Microsoft puts your VMs, right? Even on the same local area network, it doesn't mean that it's going to be on the same hardware or even the same rack. Microsoft can put it somewhere else, physically far apart from another VM that you have in your customer's network, and that can result in poor performance. Now, there is something you could do about it, right? You can set up what Microsoft calls a proximity group. So a proximity group is physically, you can tell Microsoft to put two VMs closer together in a physical fashion, right? So they'll put it on the same rack if you sort of set up a proximity group. Now, by doing that, you're putting these two machines closer together. So for whatever workload you run in that proximity group, they can perform much faster. So I have had customers who just ran simple QuickBooks workload. QuickBooks server was spun up, and then their virtual desktops with the QuickBooks client was somewhere else. And if you ping across to the QuickBooks server, you see more than 3 milliseconds response rate. And so what the fix for that client was, you can either redeploy that QuickBooks server, and magically Microsoft may put it closer to that virtual machine where the AVD sits, or if you want to tell them specifically to put it closer together, there's a button in Nerdio you can press to kind of enable proximity groups, and we'll actually put these VMs physically close to each other. Now, there's some drawbacks to that, right? So putting something physically closer together, meaning you're maybe sharing the same network or sharing the same UPS. If something happened in that area, you can have multiple VMs go out, right? So this is sort of the opposite of using an availability zone, where let's say you had a customer with two SQL servers. You can actually set them up and use SQL Enterprise and HA Peer and put them in different availability zones. So if something happened to one zone, that your SQL workload will still run, right? But if you do a proximity group, you're sort of doing the opposite of that. You're saying, hey, I'm not using your availability zones. I'm not telling you to put it randomly in any location. I'm actually telling you very, very precisely to put it to something very close, right? And so because the distance between these two servers is very close, you're going to get better latency between, network traffic between these two servers, right? So that's one aspect from an IOPS and latency standpoint. Network traffic, it matters a lot inside of Azure, not so much on an on-prem environment, because if you're using a local server or a local server with the SAN, everything is connected over iSCSI very close to each other, not a problem. But inside of Azure, because of the vastness of some of these regions, it can create a performance issue for you. Now, it's not a common thing, right? So don't think you have to pay attention to this every single time. But if you do run across a workload that requires you to move things closer together, you know that that's an option, right? So that's one aspect of it. The other aspect of it is sort of the disk attachment, right? So there's different types of disks inside of Azure. There's premium, there's standard, there's spinning disk, right? And in actuality, the disks that they physically put it on, it's all just SSD. But Microsoft creates this fictitious software-defined limit on the type of performance you get out of each type of disk. So obviously, premium SSDs are the fastest type, right? There's Ultra SSDs. Most MSPs don't use Ultra SSDs because they don't have workloads that require that type of IOPS. But the fastest SSD that MSP typically would use is a premium SSD, and the slowest type would be the standard SSD. Now, because from a physics standpoint, right, you can only have so much storage around a certain piece of hardware, right? You can pretty much assume that when you attach a premium SSD, you're pulling that SSD, that SAN storage is relatively close to the compute node. Because if that premium SSD was too far away, then Microsoft can't guarantee that transfer of data, right? All you're doing when you're renting a premium SSD and you're using it for a C drive, for example, let's say you spun up a VM and you use the C drive for the Windows volume and then the E drive for the data volume. All that stuff is actually not locally attached like that server diagram I showed you before. It's all iSCSI attached over a SAN. So even the fastest premium SSD, if you do like a disk benchmark test, you're only get it probably about 30,000 IOPS, right? And if you compare that to like an Evo 870, you're gonna get like way faster IOPS on an Evo 870, right? But if you look at the benchmarking of Evo 870, no matter what workload you throw on it on desktop perspective, you're not going to hit even like 5% of what that thing does unless you're ripping through 4K content and rendering and doing workloads like that, right? So if you're a standard user, you don't need the IOPS of an Evo 870, right? A lot of times the premium SD, even at 30,000 IOPS, is more than sufficient for your everyday sort of workload, right? So just know that distance between two VMs matter, but the type of disk you attach to it matters from an IOPS standpoint, and you got to think about distance between that storage and that VM is attached to, right? So these are things that, again, you never had to really think about when you were speccing out on-prem hardware. But to unlock the performance out of Azure, you need to understand these concepts, and it all comes back to the way that Microsoft designs its data centers. Okay, so let's talk about these disks, right? So these disks, and this is an example of a premium managed disk, right? Premium managed disks, you can see that it starts with like a 120. I mean, there's lower disks than 128, but MSPs will probably start using 128s and larger. So these 128 gig disks, if you look at the third column there, we talk about IOPS and burst IOPS, and then in the fourth column on the right, we talk about the standard throughput and the burst throughput. So these things are super important. Again, when you're on premise, you never have to think about these things because you assume your 15K RPM drive in a RAID 10 setup is more than enough to handle any of your workloads. Inside of Azure, you have to pay very close attention to this because this matters, greatly, right? So you can see that, on a 120 gig disk, you're paying almost $20 a month. This is US East pricing. You go to 256 because you double in this size, you also double in the cost, right? But you can see that the larger the disk is, the higher the IOPS and the burst throughput and the standard throughput is, right? So Microsoft's saying that, hey, if you need a larger disk, we can assume that whatever workload you throw on it is gonna require more IOPS, right? So it just kind of goes up, starting from, it kind of keeps doubling until you get to like the 1 terabyte to 2 terabyte range. It starts stabilizing, right? So at that rate, Microsoft's assuming that whatever you throw at it, that burst IOP at burst throughput is more than enough for any workload you throw on a 2 terabyte disk, for example.
Hey,
All right.
Tony.
Yes.
Jason had a question in the chat. What is the limit on the time drive that you will use its bursting speed?
So there's like a 30-minute limit, right? There's like it's a calculation thing. If you go to the Microsoft documentation for premium disk bursting, you'll see how they do it. It's not forever, right? So you know the assumption is that you're not bursting 100% of the time. If you are, you need sustained baseline IOPS that are much higher. You can use a managed disk premium V2 or go to Ultra SSD. But again, most customers' workloads don't really require that. So, but I think the documentation says the max burst limit is like 30 minutes, and then it throttles back down, and then it's almost like a B series where you build credits and then kind of burst again when you need it. So you got standard SSD, so same concept, right? Except these disks, if you look at the IOPS and throughput compared to the premium, they're much lower, right? And of course, because they're slower, right? The disk price per month is also less. Now there is a SLA difference as well between premium and standard SSD. Although I've never seen these managed SSDs fail, so you kind of take that with a grain of salt. But technically, there is an SLA difference as well, and you can kind of see once you get larger, these disks don't perform well at all, right? So they're meant to be that way. So if you need better performing disks, you need to go premium where it matters. Right, and the third type of disk we see a lot is the standard HDD type. So remember, behind the scenes, they're all SSDs. Right? These are just software limits that Microsoft limits, and they're priced accordingly. So these are, pretty much 500 IOPS all the way to 8 terabytes, right? And a lot of times people use standard HDDs for archive data. So if you have a CAD/CAM workload where a customer has 30 terabytes of data, they swear they need to access it anytime they need it to, but you want to put it into archive. This is, you could pick 16 terabytes and pay $500, right? And this is the difference. Right? Picking the right type of storage for the right workloads is going to equate to saving you a lot of money if you kind of carve it out that way. So just pay attention to that. But what I want to show you is really these VM SKUs, right? There's 5 VM SKUs in Azure. Now there's a lot more in Azure. If you look at the top row here of A series, BS, Ds, DPs, Es, EPs, there's all these other series in Azure, right? But as an MSP, you're not going to use most of them. As an MSP, you really need to know these 5, right? Because these are 5 of the ones that you can use pretty much 100% of the time. You got BS, which are burstable machines. Burstable machines are very similar to your standard machines, which are D series machines, except they're about 56% cheaper. And the reason for that is Microsoft actually over allocating these machines on purpose. So if you actually do the math, if you look at the cost of an Azure Hybrid Benefit Windows license on a B series machine, they're exactly 11 times cheaper than licensing Windows Server on a D series machine. So you can assume that Microsoft's actually over allocating these machines and sharing this, for example, a 2-core 8 gig machine with you, but also with 11 other customers, right? Or 10 other customers. So B series are great for machines that don't use a lot of CPU. There's this whole bursting credit system that it has. If you throw like a domain controller or an IIS server or utility server or an FTP server, those are perfect for B series machines because those machines don't use a lot of CPU. When you use below a certain threshold, you actually gain credits, and you gain these credits to be able to use the CPU at 100% for X amount of time. So I know it's a weird concept, but the idea is that you're selecting a B series for light workloads, and you're hoping that the light workload doesn't use, for example, more than 40%, and so that you can bank credits, and you can bank so much credits that you can actually run, if you need to, on that VM at 100% on both CPUs for, let's say, 10 hours. Right. So these are machines that you would never put like high level production workloads on, but a lot of times these are very popular because they're very cheap compared to your standard machines. But only put light workloads on them. Right. And then you got your standard machines. These are your 2-core 8 gigs. The next one up is always double the consumption. So 2-core 8 gigs. The next one up is 4-core 16. The next one up is 8-core 32. They just double, and because they double in CPU and RAM, they also double in price. So the price of a VM in Azure is very linear within the same family. Okay, so these are your standard VMs, well balanced between CPU and RAM. E is also very popular. E machines are they have the same amount of CPU as your standard machine, but they have double the RAM compared to your standard machine. So it's 2 times more RAM, about 15% more cost than your D series standard machine. And these are popular because if you're using it for virtual desktop workloads, you want RAM because RAM is something that your customers will need. They open up a million tabs in Azure or inside of a browser, you'll eat up all the memory, right? So there's something about memory that has a lot to do with performance as well, and I'll kind of explain in a little bit. Then you got your DL machines. DLs are formerly F machines. They're 2 times more CPU processor, same amount of RAM compared to your standard, and they're about like 17% more expensive. And your F series are your older alternatives. So DLs are actually still in public preview. So if you have F series machine running, start looking at see if you can when you can switch to DL machines, because they're the newest generation EPYC 3 Intel latest processors. And then finally, you have your NV GPU graphics. There's like I think 5 different series of NV machines. 2 of them are being deprecated. The NV V3s, V4s, and V5s are the ones that are still being supported. The V3s are about 5-6 years old now. They have NVIDIA graphics. The V4s have AMD Radeon graphics. They're about 2-3 years old. And then the NVV5s, which are the latest ones, they returned back to NVIDIA graphics, but they have AMD CPUs, so sort of the best of both worlds, right? You have low-cost CPUs, high value, high performance, and you have NVIDIA RTX capable, ray tracing capable graphic cards. Right, so for your workloads that demand, Lumion, right? Lumion, if you have CAD/CAM customers, AutoCAD, Revit, SolidWorks, those things work. V4, V5, no problem, but Lumion requires ray tracing, and only the V5s have ray tracing capability. So those are the 5 you need to know very well. The rest of it you can pretty much ignore because they're for workloads that you never really see as an MSP, right? For more enterprisey workloads. So how I like to think about this, if you're making a decision on what VM to pick, I kind of start in the middle. I start thinking, all right, what do I need for this particular VM, right? Is it a standard VM? Does it need more memory? If it's more memory, I go to the E series. If I need more CPU, then I need to go to the DLs. If I need the GPU, then I need to go to NVs. If my workload is very low end, I don't really care about the performance, it just needs to run, then those are the BS machines, right? The burstables. So here's kind of how you read a VM SKU, right? If you look at like the top 3 VMs I give you as an example, a lot of people look at that and go, I don't really know what it means or which ones to pick, right? This is kind of the cheat sheet to help you understand that. So the first letter inside of a SKU refers to the family. So with the family, you can understand the properties of that VM, right? So we talked about the Bs, the Ds, the Es, the Fs, or the DLs, and the NVs. Following the letter is always the number of cores of that machine. So if it's a D series machine, you can assume that if it's a 2-core machine, then it has 8 gigs of RAM. Right? If it's an 8-core machine, then it has 32 gigs of RAM. If it's a 32-core, then it probably has double the RAM. So pretty much keeps doubling, right? So it doesn't the SKU doesn't tell you the amount of memory it has. The family does, and based on the number of cores, you can assume the type of memory that family machine has. Okay, so that's the number that comes right after the letter, right? And then right after the number, there's some more letters. They're usually lowercase, but not always the case. Those are called attributes. So attributes are what characterizes the specific VM type. Now, there's way more attributes than the 4 I put there. Again, those attributes are things that MSPs don't use, so you can assume you don't need to learn them, right? So the thing about Azure is it's very hard to learn. Nobody knows everything about Azure. But if you're an MSP and you draw a box around what you need to learn, and that box is rather small, you can be an expert in that field by learning what you need to know to do your job, right? So there's lots more attributes in this, but the 4 here are the ones that you need to focus on. So A, if it has an A in the SKU, that means it's an AMD machine and not an Intel machine. If there's a D in the machine, it has a temp disk. So a temp disk actually is NVMe cache on the compute node that could be used for like a SQL transaction logs folder or ephemeral OS disk. The key thing to know about a temp disk is that when you deallocate the machine, that drive gets wiped, and so whatever data you put on that machine or that disk, you got to make sure that you don't really need it, right? That it can be perishable at any time, and it won't affect the performance or anything about the application you throw on it. The next attribute is the S. The S is it means it's premium SSD capable, right? So there are some machines that don't have the S, which means you can't attach a premium SSD to it. Right? So all comes back to data center design. That just means that if that VM doesn't have S in it, surrounding it probably doesn't have SSDs that are close enough to get the premium SSD performance. So some VMs actually don't have the S in it, right? So for the most part, you want to look for machines that have the S in it. It doesn't really cost more, right? It just means that you're picking a VM in a location in a data center that is surrounded by premium SSDs that I can use and attach them. right? And then the last attribute, it's a minus and a number sign, right? So those are called CPU constraint VMs. They're ideal for SQL workloads. So inside of Azure, you are renting SQL by the core, right? So you can't bring user cal type of licensing from on-premise into Azure when you're licensing SQL. So you have to buy them by the core. Now, sometimes a SQL workload will need lots of RAM, but not CPU, right? So if you want a machine that has 256 gigs of RAM, but only 4 cores, there is a machine for that. Okay, so that's denoted by that minus and the number sign. So if you look at that example on the top right corner, E8-4 ADS SV5, that tells me that's a 8-core 64 gig of RAM or 8-core 64 gig of RAM. Well, it's a 4-core 64 gig of RAM machine that's AMD with a temp disk and a storage and a premium storage capability. Right, so that's what that tells me. It's got an E8. Yep.
Sorry, Tony, question before we get further along. Franklin asked, in which cases do we use the D attributes?
The little d or the big D? The little d? Yeah, so the little d,
The big
yeah.
D.
Well, the big D is the family, right? So I think he's asking about the little d. The little d with the temp disk is used for like transaction logs or SQL logs, right? Logs that could be perished anytime. If you want to put your page file, right? So your page, you know, when on a normal computer, if you're using RAM, if you're like half full, Microsoft actually does a really good job of paging, you know, taking your unused memory in that RAM, lowering that to about 50%, and taking that unused RAM, putting it into your page file. That page file has a lot of IOPS requirements, right? So imagine your virtual desktop is slow because you don't have enough memory, and that it's reading and writing to your page file that could be on a slower disk. Right? Remember, these disks aren't locally attached; they're attached over iSCSI. No. So the E8 machine has 8 CPUs, but the E8 minus 4 has 4 CPUs. So it's got the properties of a full E8, but the minus 4 denotes that it's actually limited to only 4 CPUs. So when you license SQL, you're actually licensing it for 4 cores instead of the full 8 cores, but you have the memory properties of an 8-core machine, which is 64 gigs of RAM. Yep. So that's how you read it right now. The last thing I just want to finish up because I realize we don't have that much time left. The last one is generation version. You have V3s, V4s, V5s. Now it's important to know when you rent the V3 machine, which a lot of people have out there, you actually can possibly get a VM from Q3 2015. All right, so 2015 is what, 7 years old at this point. So when you deploy a V3 VM, you can possibly get a 7-year-old machine, or you could possibly get one from 2021, right? Q2 2021. So when Microsoft replaces old chips, they actually have to use the same motherboard and put the new chips back in, right? Remember, it's Microsoft's own hardware, so they could do that. And so when you pick a V3, you kind of gamble, right? V3 machines are actually more expensive than V5 machines. So when you pick a VM, you always want to pick a V5 if possible. V5s only have 2 types of processors in them, 2021 processors and 2022 processors. So not only are you getting way better performance and guaranteed the 2 latest processors, but you're paying less cost for it. Right, so hopefully this kind of helps you look at a VM SKU and think about how to pick the right one. Right, don't worry about these other attributes. There's P's out there. You know, I saw an MSP the other day deploy an ARM processor running Windows Server on it, and he just didn't know. Right, he just randomly picked one. I'm like, hey man, you know, when you're running ARM processors, you're emulating Windows on the x64 code, and you're probably getting slower performance than but he just didn't know. Right, so don't randomly pick the machines based on CPU and RAM. Really know what the SKUs mean. And if it's a SKU that's not the 4 here, ignore it because it doesn't, you know, it's not for MSP workloads. Okay, so that's the thing I wanted to let you guys know. All right, so I'm gonna skip the pop quiz because I was gonna quiz you guys on like what these mean. Right, I usually do that in class. And if you look at the scan me code on the top, that's our link to our cheat sheet. It gives you this and way more information about how to pick the right size VM and storage. The last thing I want to show you is that your workload's only going to be as fast as your lowest common denominator, right? So here in the bottom, I have again that chart for the premium disks, right? So let's say I have a 2 terabyte premium disk and I assign it to a B2MS machine, a burstable 2-core 8 gig machine, right? So if you look at the top, the first 3 machines are 2-core 8 gig machines. But if you look at the Microsoft documentation, the machines can take only so much throughput and IOPS, and they're advertised. So the biggest mistake a CMSPs do is actually picking a disk that's premium and attaching it to a VM that can't even take advantage of those throughputs and IOPS numbers, right? So if you, a lot of people I see I have V3 workloads. If you have a 2 terabyte disk and go 7,500 IOPS, it bursts up to 30,000, and I attach it to a 2-core 8 gig V3 machine, I can only get 48 megs from that, or burst up to 200 megs. But if I switch that VM from a V3 to V5, I can get double the throughput baseline and more than double, like almost 6 times faster burst IOPS for that disk. Right, so this is the last thing I'll leave you guys with. But your workload is only as fast as the lowest common denominator between the relationship of a premium disk and the VM you attach it to. So it's super important, right? Your VM has advertised max throughput and IOPS, from a disk. And if you're picking a premium disk because you want the performance, always make sure that the VM you pick meets that requirement. Otherwise, you're being bottlenecked, and sometimes you're bottlenecked so much, like that B series machine. There's no point in putting paying for a 2 terabyte disk when I could have paid for a 2 terabyte spinning disk, and that machine can't even take advantage of that disk, right? So that's the last thing I'll leave you. I'll maybe stick around for maybe 2 more minutes and answer any questions, but this is a quick 30-minute thing about how to pick the right VMs and make sure the performance of that is right.
Tony, there was a question 2 minutes ago that Peter asked if you want to read that, so I don't have to call it out loud.
So the D16 ASB4 has a temp disk storage, 100 SSD. Why no D? Okay, so that's a great question, Peter. So in V3 and V4 machines, V3 machines all had temp disks, right? There was no option. The little D character didn't exist at that time period. So over in the middle of V4s coming out, they introduced a little attribute with D. So starting V4, some V4 machines have the D and it denotes has a temp disk. Some V4s actually don't have a little D and it has a temp disk in it. And then from V5s and on, they started splitting machines that have temp disk and no temp disks. So that's something that you caught, which is really good. But if you're learning Azure from today on and you're only using V4 and V5 machines, that is true. But if you're coming from a V3, that is not true, because all V3s had temp disks, and even though it didn't have the little D. It's a good catch, Peter. All right, guys. Yeah, we run these training camps. We actually have a 2-day event. It's free to go to, and it's we even pay for the hotels. So imagine having 2 days of deep dive content like this. That's what our Nerdio training camps are all about. So reach out to your partner sales executive to learn more about them. Again, they're free to attend. They're 2-day training camps for salespeople and technical people, and we pay for the hotel. So no brainer to attend. All right, guys. Hopefully that was some you learned, and I'll see you guys next time.